A new
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
tool. What if its true purpose was to deliver the very seeds of life to a young and waiting Earth? This idea is no longer just for science fiction. It is being debated by serious minds. The universe is vast and mostly empty. Yet, against all odds, objects cross the immense distances between stars. We are just beginning to catalog these interstellar travelers. Each one that passes through our cosmic neighborhood is a priceless opportunity. It is a sample from another star system, delivered right to our doorstep. For generations, we have looked up at the stars and wondered if we are alone. We have sent our own messages into the void, like the Voyager Golden Records. What if someone, or something, has already sent a reply? The discussion around this comet is not just about astronomy. Astronomy, biology, philosophy, our deepest sense of self. The theory, proposed by researchers at Harvard, pushes the boundaries of conventional thinking. It asks us to consider that the origin of life on our own planet might not have been a local event. It suggests that life's beginning could be a story of cosmic seeding. This is a dramatic and potentially world-changing concept. It reframes our existence, suggesting we might be part of a much larger, interconnected galactic biosphere. The implications of such a discovery would be staggering, forcing a re-evaluation of everything we thought we knew. So, we stand at a crossroads of discovery, looking at a faint point of light moving against the backdrop of distant stars. Is it merely a natural remnant from the formation of a faraway solar system, flung out by gravitational chaos? Or is it something more? Is it a package, a probe, a seed pod on a mission that began millions of years ago, sent by a civilization we can only dream of? The journey to find the answer begins now. We must follow the evidence where it leads, no matter how strange the destination. The mystery of 3I/Atlas is the mystery of our own origins. Well, let's keep going. Signifying it is not from around here. Most comets we see are members of our own solar system. They orbit our sun in vast, looping paths. But some objects are just passing through. They travel on a hyperbolic trajectory, meaning they approach our sun from the blackness between stars, swing around it once, and then head back out into the deep, never to return. 3I/Atlas is the third such object we have confirmed, a rare and precious messenger from another star's domain. Our first encounter was in 2017. That visitor was named Oumuamua. In 2019, we found a second, 2I Borisov. Now we have 3I/Atlas. Each guest is unique. Each provides a new piece of the puzzle about other solar systems. By studying them, we learn about chemical makeup and physical processes. They are like geological samples from an alien world, delivered free of charge. The path of 3I/Atlas tells its story. It entered at high velocity, too fast to be captured by our sun. It's on a one-way trip through our cosmic backyard. As it passes, telescopes worldwide lock on. We analyze the light it reflects and emits. This light acts like a fingerprint, telling us about its composition. We can determine its size, its shape, and what it is made of. This data tests theories of origin and the bolder ideas. Maybe it's special, maybe artificial. Studying them is a race against time. 3I/Atlas won't be here long. Every day it gets farther away and fainter. The window to gather information is short. Scientists use every instrument they have to observe. They look for anomalies beyond natural comet behavior. Every photon collected is a clue. It might be a clue about planetary formation, or it could point toward a far more spectacular conclusion about life in the universe. That's the situation. Recently, a paper from researchers at Harvard University sent ripples through the scientific community. The authors, led by astrophysicist Avi Loeb, explored a truly startling idea. They proposed that some interstellar objects might not be random debris at all. Instead, they could be artifacts of an advanced alien civilization. More specifically, they could be probes designed to seed life on other worlds. The concept itself is an old one, known as panspermia. But applying it to a specific observed object like 3I/Atlas brings the theory from the realm of abstract thought into the world of testable science. This is a bold and provocative step. The Harvard team did not claim that 3I/Atlas is definitively an alien probe. Science does not work that way. Instead, they engaged in a thought experiment based on the available data. They asked a simple but profound question. If an advanced civilization wanted to spread life throughout the galaxy, how might they do it? Sending massive, crude starships would be incredibly difficult and energy-intensive. A much more efficient method would be to send countless small, durable probes. These probes could be disguised as comets or asteroids, designed to carry microbial life or the chemical building blocks of life, protected within ice and rock for their long journey. This idea is known as directed panspermia. It suggests that the emergence of life on Earth might not have been an accident of local chemistry. It might have been a deliberate act. The Harvard paper explored the physics of such a mission. It calculated how a mothership in a distant star system could release small probes into its path. These probes would then be scattered like dandelion seeds on the cosmic wind, eventually entering other solar systems. Some might, over millions of years, land on a habitable planet like Earth. The theory connects the dots between alien intelligence interstellar objects and the origin of life itself. The publication of this hypothesis was met with both excitement and skepticism. Many scientists argue that there is no need for such an extraordinary explanation. They believe that all the features of objects like 3I/Atlas can be explained by known natural processes. However, the paper has succeeded in its primary goal. It has forced the scientific community to think outside the box. It has made it acceptable to ask what if. It challenges us to consider that if we are looking for signs of extraterrestrial life, we should not just be looking for radio signals. We should also be looking at the very rocks and ice that fly through our own solar system. Well, that's where the idea leads us. To understand the context for the 3I/Atlas theory, we must look back to Oumuamua. When this first interstellar visitor was detected in 2017, it immediately struck scientists as bizarre. It was small, dark, highly elongated shaped, perhaps like a cigar or a flat pancake. Most strangely, as it moved away from the sun, it accelerated. It sped up in a way that could not be explained by the sun's gravity alone. This non-gravitational acceleration is the key part of its mystery. For normal comets, this push is caused by ice turning into gas and shooting out like a tiny rocket engine, a process called outgassing. But we saw no gas tail around Oumuamua. This lack of a visible tail led to a major scientific debate. Some astronomers proposed that the outgassing was made of molecules we couldn't easily see, like pure hydrogen. Others suggested more exotic natural explanations. But Avi Loeb, the same Harvard scientist behind the 3I/Atlas paper, offered a more radical idea. He suggested that Oumuamua's acceleration could be caused by the pressure of sunlight pushing on a very thin, very light object. In other words, it could be a solar sail, a piece of technology. This theory propelled the idea of alien artifacts from science fiction into mainstream scientific discussion. The debate over Oumuamua primed us for these conversations. Now comes 3I/Atlas, and it presents a different picture. Unlike Oumuamua, 3I/Atlas does appear to have a faint cometary tail. This suggests that it is, in fact, outgassing. On the surface, this makes it look much more like a conventional natural comet. It seems less mysterious than its predecessor. But this does not close the door on the directed panspermia hypothesis. In fact, for the purpose of seeding life, a comet-like object is actually a perfect vehicle. Its icy shell provides excellent protection against the harsh radiation of deep space, shielding any organic cargo held within. Therefore, the comparison between the two objects is fascinating. Oumuamua looked like a potential piece of hardware, a probe ship. 3I/Atlas looks more like a natural container. If an alien civilization were to design a seed pod, they might engineer it to look and act exactly like a comet. It would be the perfect camouflage. It would use natural outgassing to make small course corrections. It would break apart in a planet's atmosphere to disperse its contents. So, while 3I/Atlas appears less strange than Oumuamua at first glance, it could, in theory, be an even better candidate for a biological seeding mission. The core idea behind the Harvard theory is called panspermia. Let's break this concept down. The word comes from Greek, seeds everywhere. It's the hypothesis that life exists across the universe. It's distributed by space dust, meteoroids, asteroids, comets. Imagine life as a resilient dandelion seed. The wind carries it across a field, letting it take root in a new spot. In the cosmic story, wind equals gravity from stars and planets. Seeds are microscopic life forms, or chemical precursors. Carriers can be rocks or ice. There are several versions of this theory. The most basic is accidental panspermia. An asteroid could crash into a life-bearing planet. Example, early Earth. Example, Mars. The impact can blast rocks with hardy microbes into space. Those rocks can travel millions of years, then crash on another habitable world, restarting life. It's a purely natural process. We have meteorites on Earth known to come from Mars, so rocks do travel between planets. It's plausible, though unproven, as a mechanism to spread life. A more intriguing version is directed panspermia. That idea says seeding could be intentional. An advanced civilization deliberately sent life, or the building blocks of life. Reasons? Duty to spread life, create a galactic legacy, a long-term experiment. This is what the Harvard paper applies to 3IATLAS. It suggests the comet was not just a carrier, but a courier. Why is this so compelling? Life on Earth appeared very quickly after habitability. Conditions were harsh. We still don't fully understand how life emerged from non-living chemicals. Panspermia offers a potential shortcut. If complex organic molecules arrived from space, or even the first simple cells, it could explain how life got started so fast. It doesn't solve the ultimate mystery of how life began. It simply moves the origin event elsewhere, earlier in the universe. What evidence could possibly support the extraordinary claim that 3I/Atlas was sent by aliens? The argument rests on a chain of circumstantial points, not on a single smoking gun. First, there is the simple fact that interstellar objects exist and can travel from one star system to another. This confirms that a physical delivery mechanism is possible. Second, some of these objects, like Oumuamua, exhibit strange behaviors that are difficult to explain with conventional physics. This opens the door to considering non-natural explanations, including the possibility of technology. It makes us question our assumptions about what is, normal in space. Third, we know that life is incredibly resilient. Certain microorganisms, called extremophiles, can survive extreme conditions of cold heat and radiation. Some can enter a dormant state for thousands or even millions of years encased in ice or salt. This biological fact makes it plausible that microbes could survive a long journey through interstellar space, especially if they are shielded inside a comet. Fourth, we know that comets and asteroids are rich in organic molecules, the chemical building blocks of life. Discovering these complex molecules in space shows that the raw ingredients for life are not unique to Earth. The argument for design also relies on a kind of cosmic logic. An advanced civilization looking to propagate life would likely choose the most efficient method. A small, self-sustaining probe designed to look like a comet would be an ideal choice. It would be durable, well camouflaged, and capable of using natural forces like solar radiation and gravity to its advantage. The civilization could send out billions of these probes, playing a numbers game. Even if only 1 in a billion successfully seeds a planet, the mission would be a success. The argument is that this strategy is so logical that we should expect a mature civilization to attempt it. Finally, there is the concept of looking for a message or a pattern. If 3I/Atlas were an artificial seed pod, it might contain a sign of its makers. This would not necessarily be a radio signal. It could be a highly unusual isotopic ratio in its chemical makeup. It could be a complex polymer chain that encodes information, like a form of alien DNA. It could even be a physical artifact buried deep within the ice. Proponents of the theory argue that we must look for these specific, unnatural signatures before we can rule out the possibility of intelligent design. For every argument supporting an artificial origin for 3I/Atlas, there is a strong and simple counter-argument rooted in natural processes. Science operates on a principle often called Occam's razor. The simplest explanation is usually the best one. The claim that 3I/Atlas is a natural comet is by far the simpler explanation. Our galaxy is filled with billions of stars. During the formation of solar systems, countless comets, asteroids are formed. The gravitational interactions between large planets can easily eject these smaller bodies, flinging them out into interstellar space. It is a natural and expected consequence of planetary dynamics. Therefore, the presence of interstellar objects is not, in itself, mysterious. It is exactly what our models of galaxy formation predict. We should expect to see a steady stream of these visitors passing through our system. In fact, the only surprise is that it took us so long to start finding them. This is likely just because our telescopes are only now becoming sensitive enough to spot these small, fast-moving, faint objects. As our technology improves, we will almost certainly find many more of them. The idea that any single one is artificial becomes less likely as the total number of natural ones grows. Furthermore, the strange behaviors of these objects often have plausible natural explanations. The acceleration of Oumuamua, for instance, could have been caused by the outgassing of hydrogen ice, which would be invisible to our telescopes. Or it could have been a nitrogen iceberg chipped off a Pluto-like object in another solar system. For 3I/Atlas, its comet-like appearance strongly suggests it is a natural object behaving as expected. There is currently no observation of 3I/Atlas that requires an alien explanation. Nature is creative and complex, and it can produce phenomena that surprise us without needing to invoke intelligence. The most significant argument against the artificial hypothesis is the lack of extraordinary evidence. The claim that aliens have sent a probe to our solar system is one of the most extraordinary claims one could make. To be accepted, it would require proof that is direct, unambiguous, overwhelming. So far, we have nothing of the sort. We have speculation based on limited data. We have interesting thought experiments, but we do not have a photograph of a circuit board, an analysis of an artificial chemical, a decoded alien message. Until such evidence is presented, the scientific consensus will, and should, remain with the natural explanation. Let us step away from the scientific debate for a moment and consider the human implications. What if we found conclusive proof? What if a future space mission intercepted an object like 3I/Atlas and discovered microbes with a genetic code unlike anything on Earth or a clear technological artifact inside? The impact on our civilization would be profound and irreversible. It would fundamentally change our understanding of our place in the universe. It would answer the age-old question, are we alone? With a definitive no. It would prove that we are part of a larger cosmic story. This discovery would trigger a revolution in science and philosophy. Biologists would have a second example of life to study, allowing them to finally understand which principles of life are universal and which are unique to Earth. The origin of life on our own planet would be recast not as a singular miracle, but as the result of a cosmic delivery. Religions and belief systems around the world would be forced to grapple with this knowledge. It could lead to new spiritual movements, or it could be integrated into existing faiths. On a societal level, confirmation of directed panspermia would be a unifying event. The knowledge that our existence is owed to a distant, ancient intelligence would change how we see ourselves. National boundaries and political squabbles might seem petty. It could inspire a new era of global cooperation focused on understanding our origins. We would look at the stars not just with wonder, but with a sense of connection, a sense of family. We would be the children of a star-faring civilization. Of course, there would also be fear and uncertainty. Who were these seeders? What were their motives? Do they still exist? Are they watching us? The discovery would raise as many questions as it answers. It could lead to cosmic paranoia or a feeling of inadequacy, but it would also give humanity a new grand purpose: to explore the stars, to learn more about our creators, and perhaps one day to continue their work of spreading life throughout the galaxy. The story of humanity would become the next chapter in a much older, larger epic. We find ourselves in a moment of profound mystery. An object from another star, 3I/Atlas, is speeding through our solar system. It is most likely a natural piece of cosmic debris, a lonely wanderer on an endless journey. But a few bold minds have asked us to consider a more radical possibility: that it is a messenger, a courier, a seed of life sent with purpose. Right now, we do not have the evidence to confirm this extraordinary claim. The data we have is limited, and the object itself is already moving back into the darkness from which it came. The mystery remains open. The scientific process is now in full swing. Curiosity must be balanced with healthy skepticism. We must welcome bold and imaginative ideas because they push the boundaries of our knowledge. But we must also hold those ideas to the highest standard of evidence. The claim that aliens sent a comet to Earth is testable. We can look for specific chemical signatures. We can analyze its trajectory for any unnatural movements. We can compare it to the dozens of other interstellar objects we will surely discover in the coming years. This is how we will slowly move from speculation toward understanding. The true legacy of 3I/Atlas and Oumuamua before it might not be the answer they provide, but the questions they inspire. Their arrival has pushed us to build better telescopes. It has motivated engineers to design missions that could one day intercept one of these interstellar visitors. Imagine a spacecraft that could rendezvous with such an object, land on its surface, and even bring a sample back to Earth. Such a mission would be one of the most difficult and rewarding ever attempted. It is the only way we might ever get a definitive answer. So we are left looking up at an open sky, filled with more possibilities than ever before. These visitors from afar have reminded us that our solar system is not an isolated island, but part of a vast, interconnected galaxy. They challenge us to think bigger, to look deeper, and to never stop asking questions. The truth about our origins is out there, waiting to be discovered. The search is on, and it is a search that unites all of humanity. Was the spark of life on Earth a local accident of chemistry, or was it a gift from the stars?